Hello and welcome back to Calculus Explained. Today we are going to cover algebraic limit techniques, or how to actually compute limits. So in the last video we built on an understanding of what a limit means. Today we'll learn how to actually compute limits using algebra. These are the three tools that you need to get through about 90% of beginner limit problems. The first is direct substitution. So if the function is nice, meaning continuous, we can just plug it in. One example of this is this limit here, limit of x to 3 of 2x plus 1. Here you can just substitute in the 3 to get 7. Another one might be limit of x to negative 1 of x cubed plus x. Here you can just substitute it in. And you get negative 2. So an example of where this wouldn't work, for example, is limit of x to 2 of x squared minus 4 over x minus 2. Here you get 0 over 0. This is called an indeterminate form. When you have an indeterminate form, you need more work. So that is where our other methods, factoring and canceling, and rationalization, come in. For factor and cancel, this is when substitution fails because of that indeterminate form, 0 over 0. So the next step is to simplify. Most of the time, it really helps to factor the numerator. One example is our previous problem, squared minus 4 over x minus 2. Here, this is a difference of squares, so we factor, we cancel, and we are left with the limit of x to 2 of x plus 2. Now you can use direct substitution and get 4. Another example, limit of x to 1 of x squared minus 3x plus 2 over x minus 1. Here you can factor the numerator. You get x minus 1, x minus 2 over x minus 1. You cancel, and then you are left with limit of x to 1 of x minus 2. Now you can use direct substitution, and you get 1 minus 2 equals negative 1. So that is when you would need factoring and canceling in order to solve a limit. Now the last case is rationalization. For rationalization, when square roots are involved, factoring isn't necessarily going to help. Instead, we have to multiply by the conjugate of that rational expression. So one example of this might be the limit of x to 0 of root x plus 1 minus 1 over x. Now in this scenario, we multiply by the conjugate, which is root x plus 1 in both the numerator and the denominator. And from there, you get x over x times root x plus 1. Cancel that out, and then you are left with limit of x to 0 of 1 over root x plus 1. And then this just simplifies to 1/2. Now another scenario, limit of x to 4 of 2 minus root x over 4 minus x. Here you multiply by the conjugate, which is 2 plus root x over 2 plus root x. And then you get limit of x to 4 of 4 minus x over 4 minus x times 2 plus root x. You cancel. And then you have limit of x to 4 of 1 over 2 plus root x. This simplifies to 1 over 2 plus 2 equals 1/4. So that is how you would use rationalization to get your answer for a limit. Now some common pitfalls are 1, canceling incorrectly. For factor and cancel, make sure that you are factoring the numerator correctly and then canceling accordingly. Now another is plugging in before you simplify. If you ever see 0 over 0, stop and simplify first, and then proceed using algebraic techniques. Another might be assuming 0 over 0 equals 0. So this is never the case, or not always the case, rather. This is not true. You don't want to assume this. It's indeterminate. It is when you see 0 over 0 that you want to use your factor and cancel or rationalization methods. So whenever you see 0 over 0, you just know that you need work to find the correct answer. Later, we'll see indeterminate forms like infinity over infinity, 0 times infinity, infinity minus infinity, or 1 to infinity. And that's where L'Hopital's rule will come in later on. So let's do some practice problems. Pause the video, go through these, and when you're done, unpause the video, and we'll go through them together. Welcome back. Now we will go through each of the problems together. So for this one, you can factor the numerator to get limit of x to 3, x minus 2, x minus 3, over x minus 3, cancel. Then you get limit of x to 3 of x minus 2 equals 1. Now for the next problem, we multiply by the conjugate, which is root x plus 9 plus 3 over root x plus 9 plus 3. You get limit of x to 0 of x over x times that conjugate, root x plus 9 plus 3. Cancel. You are left with limit of x to 0 of 1 over root x plus 9 plus 3. This simplifies to 1/6. Now for our last problem, we can simplify to get limit of x to 3 of root x minus 3. And this is just root 0 equals 0. So that concludes this video. Today we learned about the 3 main algebraic tools for computing limits. Next video, we'll look at limits to infinity, how functions behave far out on the number line, and that's where horizontal asymptotes come from. I hope you enjoyed this video, and I will see you next time.